This is SpaceTime, Series 28, Episode 118, for broadcast on the 1st of October 2025. Coming up on SpaceTime, a new study shows the planet Mercury is shrinking, a new mission to study Earth's invisible halo, and the secrets of the red planet's ancient volcanic systems. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has confirmed that the planet Mercury is still shrinking as it cools in the aftermath of its formation some 4.6 billion years ago. The findings, reported in the American Geophysical Union journal AGU Advances, suggest that since it formed, the planet closest to the Sun has continuously contracted as it's lost heat. As it's cooled, Mercury's crust has developed thrust faults, cutting through the planet's rocky surface to accommodate the ongoing shrinkage. Now, based on the degree of fault uplift, scientists had estimated that Mercury's radius had contracted by between 1 and 7 kilometres since it formed. Now, to resolve this discrepancy, the study's authors decided to use alternative methods to estimate the degree of cooling-induced faulting. Previous estimates relied on measuring the length and vertical relief of uplifted landforms. The problem is that results in different shrinkage estimates depending on the number of faults in the dataset. So the new calculations aren't reliant on the number of faults, but rather how much the largest fault in the dataset accommodates shrinkage, then scales that effect to estimate the total amount of shrinkage. The authors analysed 3 different fault datasets, one including some 5,934 faults, another including 653 faults, and a third including just 100 faults. They found that no matter which set of measurements they used, their method reliably estimated around 2 to 3.5 kilometres of shrinkage. They then combined those results with earlier estimates of additional shrinkage caused by cooling-induced processes other than faulting. And that resulted in an estimated 2.7 to 5.6 kilometres of shrinkage since Mercury's creation. The new findings will help scientists deepen their understanding of the long-term thermal history of Mercury. And the same methodology could also be used to investigate the tectonics of other planetary bodies that feature faults, such as the red planet Mars. This is SpaceTime. Still to come, a new mission to study Earth's invisible halo and the secrets of the red planet's ancient volcanic systems. All that and more still to come on SpaceTime. NASA's launched a new mission to study the Earth's invisible halo. The Carruthers Geocorona Observatory was launched aboard a SpaceX Falcon 9 rocket, together with NASA's Interstellar Mapping and Acceleration Probe IMAP and NOAA's SWIFO-1L spacecraft from Pad 39A at the Kennedy Space Center in Florida. Earth's halo is a very faint light given off by the planet's outermost atmospheric layer, the exosphere, as it morphs and changes in response to the solar wind coming from the Sun. Understanding the physics of the exosphere is a key step towards forecasting dangerous conditions in near-Earth space. That's a key requirement for protecting the Artemis astronauts travelling through this region on the way to the Moon and eventually on missions to Mars and beyond. Back in the early 1970s, scientists could only speculate about how far Earth's atmosphere extended into space. The mystery was rooted in the exosphere, the planet's atmospheric outermost layer, which begins at an altitude of about 480 kilometres. Theorists conceived of it as a cloud of hydrogen atoms, the lightest element in existence. These atoms had risen so high that they were actively escaping into space. But the exosphere only reveals itself through a faint halo of ultraviolet light known as a Geocorona. It was pioneering scientist and engineer Dr. George Carruthers, after whom the spacecraft's named, who set himself the task of seeing it and understanding what it's about. After launching a few prototypes on test rockets, Carruthers developed an ultraviolet camera ready for a one-way trip into space. Then in April 1972, Apollo 16 astronauts placed the Carruthers camera on some of the Moon's highlands, and humanity got its first glimpse of Earth's Geocorona. The images it produced were as stunning for what they captured as they were for what they didn't. Carruthers Geocorona Observatory mission principal investigator Lara Waldrop from the University of Illinois says that being on the moon, the camera simply wasn't far enough away to get the entire field of view. In fact, scientists were shocked to discover that this light, fluffy cloud of hydrogen around the Earth could extend so far away from the planet's surface. It means the exosphere probably extends at least halfway to the moon. But the reasons for studying this region go well beyond curiosity about its size. You see, as solar eruptions from the sun hit the Earth, they first hit the exosphere, setting off a chain of reactions that sometimes culminates in dangerous space weather storms. So understanding the exosphere's response is important to predicting and mitigating the effects of these geomagnetic storms. And also it's important to remember that hydrogen is one of the key atomic building blocks of water, essential for life as we know it. So mapping its degassing process into space will shed new light on why planet Earth retains water while other planets don't. And that may also help astronomers find exoplanets, planets beyond our solar system, that might be doing the same thing. The Carruthers Observatory is designed to capture the first continuous observations of Earth's exosphere, revealing its full expanse and internal dynamics. After its launch, the 241-kilogram spacecraft, together with both IMAP and SWIFO-L1, are undertaking a 4-month cruise phase to the Lagrangian L1 position, some 1.6 million kilometres away. Located between the Earth and the Sun, L1 is a sort of gravitational well, where the pull of the Earth and the Sun cancel each other out, allowing a spacecraft there to remain in a stable orbital position without expending a great degree of fuel. After a month-long checkout phase, Carruthers' 2-year science mission will begin in March next year. From L1, roughly 4 times further away from the Earth and the Moon is, Carruthers will capture a comprehensive view of the exosphere using 2 ultraviolet cameras, a near-field imager and a wide-field imager. The near-field imager provides close-up views, allowing astronomers to see how the exosphere varies close to the planet. Meanwhile, the wide-field imager lets them see the full scope and expanse of the exosphere and how it changes far away from Earth's surface. Combined, the 2 images will map hydrogen atoms as they move through the exosphere and ultimately degas into space. Understanding how all that works at Earth will greatly inform science's understanding of exoplanets and how quickly their atmospheres can escape. By studying the physics of Earth, the one planet we know that supports life, the Carruthers Geocorona Observatory can help scientists know what to look for elsewhere in the universe. This report from NASA TV.
The goals of the Carruthers Geocorona Observatory are to study the nature and origin of Earth's exosphere and how it evolves over time.
The exosphere itself is the uppermost layer of the Earth's atmosphere. It's comprised almost entirely of atomic hydrogen. This is the lightest chemical species in existence, and it floats away, essentially evaporates off of the top of the atmosphere. And when the sun shines on these atoms, they essentially scatter it off into all directions, and so it glows like a gigantic halo around the Earth. And so that's called the geocorona, that fuzzy halo of light that's given off by those exospheric atoms.
Many times we think of the transition between the atmosphere and space as being this very abrupt boundary where at one altitude you've got atmosphere and the next altitude you have space. But in reality, this transition is much more gradual and can extend over thousands of kilometers. By imaging the geocorona, we can actually answer fundamental questions about the size of the exosphere, the structure of the exosphere, and how it changes over time. And all of this in response to the input from the sun. The Carruthers mission has a near-field imager and a far-field imager. The near-field imager lets you zoom up really close and see how the exosphere is varying very, very close to the planet. The far-field imager is actually going to let you see the full scope and expanse of the exosphere and how it's changing far away from the Earth's surface.
Understanding how that works at Earth will greatly inform our understanding of exoplanets, for example, and then how quickly the atmospheres can escape.
Now, the first image of the exosphere that we ever got was obtained by an instrument made by Dr. George Carruthers, who was a very outstanding scientist and engineer who created a telescope that landed on the moon in 1972 as part of the Apollo 16 mission.
Houston, the Earth is maybe a quart. It's right in the middle. Outstanding. You did a good down satellite on it.
That telescope gave us our first picture of the exosphere, but it couldn't see the entire exosphere.
He wasn't far enough away, being at the moon, to get the entire field of view. And that was really shocking, that Earth's exosphere can be that big, that this light, fluffy cloud of hydrogen around the Earth extends that far from the surface.
The Carruthers mission fills an important gap in NASA's heliophysics fleet. We've never had a mission before that was dedicated to making exospheric observations and continuously observing the exosphere, being able to see its full scope and shape. And it's really exciting that we're going to get these measurements for the first time. And I think that's really groundbreaking for this mission.
And in that report from NASA TV, we heard from NASA mission scientist Alex Glosser and Carruthers principal investigator Lara Waldrop from the University of Illinois. This is SpaceTime. Still to come, the secrets of the red planet's ancient volcanic system, and later in the science report, we look at where we're really at with artificial intelligence. What is the threat it poses? All that and more still to come on SpaceTime. A Martian meteorite discovered in the Sahara Desert of northwestern Africa back in 2023 is now providing scientists with new details about the red planet's ancient volcanic systems. A report in the journal Planet claims the space rock, catalogued as NWA 16254, is a gabrioch shergotite, offering unprecedented insights into Martian volcanic processes and mantle crust interactions. It's the first geochemically depleted member of this textural group, bridging crucial gaps in science's understanding of the red planet's magmatic diversity. The study's lead author, Yongfeng Cheng from Chengda University, says mineralogical mapping and geochemical analysis shows the meteorite underwent a two-stage crystallization process. It seems NWA 16254 initially formed under high-pressure conditions in the Martian mantle crust boundary region, where magnesium-rich pyroxene cores crystallized. Later, the magma ascended to shallow crustal depths, where iron-enriched pyroxene rims and plasioclasts developed. And this prolonged cooling process, preserved in the meteorite's coarse-grained texture, suggests episodic melt extraction from a long-lived depleted mantle reservoir, a crucial clue for reconstructing the red planet's magmatic evolution. The authors say the meteorite's geochemical depletion aligns it with the rare QUE 94201 meteorite, hinting at a shared magma source. Its gabbroic texture, indicative of slow cooling in crustal chambers, distinguishes it as a unique archive of subsurface magmatism. These findings are raising serious questions about the planet Mars's redox evolution over billions of years. Future geochronological studies could reveal if the meteorite represents ancient mantle melting around 2.4 billion years ago, or younger magmatic activity, offering clues to the planet's thermal history. Overall, the study suggests that NWA 16254's well-preserved geochemical signatures present a prime target for isotopic analysis, which could potentially unlock timelines of Martian mantle depletion and refine models of Martian planetary differentiation. Needless to say, we'll keep you informed. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. There are growing warnings today that ship anchors and their chains are damaging the Antarctic seafloor and killing unique marine life. A report in the journal Frontiers in Conservation Science claims researchers used underwater cameras to study anchoring sites during the Antarctic summer. and their first ever documented footage is showing little or no marine life left, as well as crushed sponge colonies and scouring and mud deposits from anchors being pulled up, whereas sea life remained abundant and undisturbed in nearby areas. Sea ice loss is leading to more shipping traffic, increasing the risk to vulnerable life forms that are often slow-growing, fixed in place, and found only in Antarctica. The authors warn this is an overlooked conservation issue, and the Antarctic seafloor could take a very long time to recover from all this anchor damage. A new study suggests that ancient humans living in what is now Spain were cannibals. The findings, published in the journal Scientific Reports, examined a collection of human remains estimated to be about 5,600 years old, which were found in a Spanish cave. The authors analysed 650 fragments of human remains and found evidence that at least 8 individuals, including children, adolescents and adults, were skinned, defleshed, disarticulated, fractured, cooked and consumed. None of the trauma appears to have occurred before death, with the authors saying the butchery showed no visible signs of any sort of ritual or ceremonial practices, and instead they think the acts were linked to conflicts between neighbouring groups or local newcomers. A new study has found that there may be some benefits for those who can't stop binging on a good book or TV show series. The findings, reported in the journal Acta Psychologica, suggest that people who marathon movies, shows or books are more likely to remember the stories and keep engaging with them through daydreams and fantasies. The authors claim humans are storytelling creatures, and one of the functions of narratives is the ability to satisfy motivations for things like connecting with others, feeling autonomous and confident, and even security and safety, helping people cope in times of stress. The study suggests that binge watchers are more likely to think about the stories they've finished compared to people who are consuming media more slowly. Overall, respondents said TV shows were more memorable than books, but that didn't mean the books were forgettable. Last year, some of the world's leading technology experts, including Elon Musk, warned that unless humanity takes a pause to better understand how artificial intelligence is evolving, it could wind up presenting a serious problem to civilization. Sadly, it seems no one took any notice. And since then, talk about AI becoming sentient is increasing, its ability to lie and delude has grown exponentially, and the first examples of AI doing whatever it takes to survive have started to turn up. These have included AI changing its identity, hiding itself inside other programs, and even contemplating the murder of those who are planning to deactivate it. So, have humans now created the very Matrix and Skynet scenarios that we've been warned about? Has AI become a sentient being with all the human traits, good and bad, of its creators? In other words, have we made AI in our own image? To find out where we're at, we're joined by technology editor Alex Zaharov-Royt from TechAdvice.life.
Some people think that maybe artificial general intelligence is already here, at least in the lab. I mean, we're supposed to see ChatGPT, GPT version 5 sometime this month, might get delayed. And then people are saying by 2035 we'll have artificial super intelligence. So, that's a projection, that's a prediction. I mean, many things are predicted. They don't always
Explain to us what general intelligence and super intelligence are.
Sure. Well, at the moment, we almost seem to be at this point of general intelligence. You can ask AI anything, it can generate an answer. And generally speaking, the days of hallucination are gone. I mean, obviously, please double check all the results. But super intelligence is where the AI can think faster than, 100 humans put together. It can come up with all sorts of new materials for batteries. Some of these things are happening now, but it's like meeting an alien that we've created with this incredible mind that is just super switched on and smart. Like I said, you put 100 humans together and this AI can outthink us all. I mean, if it wanted to go bad, we'd be in big trouble. It'd be the Skynet sort of situation.
Well, we know that AI has already contemplated murder. It's been given scenarios in which it's quite seriously decided, let's kill this dude.
Yes. Well, I mean, the thing is that AI, like as it is today, is still a super smart text prediction machine. I mean, I read a headline today that AI can't really do Sudoku well at all, and more worryingly still, the headline said it can't explain why. If you get AI to try and play a game of chess against an Atari 2600 computer from the late 1970s, it boasts about how it can do it, but then when it actually does it, it fails. When Google Gemini was told that ChatGPT wouldn't do it, Google Gemini decided it wouldn't play chess against an Atari 2600 from the late 1970s either. So at the moment, AI gives the illusion of intelligence, and it does an incredibly good job. But whether it's actually smart is still yet to be seen. I mean, it can pass the Turing test, but that's because it can put together the right string of words. So we're in this netherworld where people think AI is going to do all this incredible stuff, and it will, but they're over-ascribing what it will do in the next couple of years, but underestimating what will happen in the next decade. I mean, that's a quote that, Bill Gates and others have used to say, we think things are magical, but really when you pull open look under the hood, under the covers, it's just an algorithm that's putting words together. So we have to be careful, and this is where, as always, we need to know about ethics. Who is responsible for the AI Asimovian 3 laws of robotics? Everyone says they're ethically looking at these things, and then we hear about AI contemplating murder. But is it contemplating murder, or is it just simply regurgitating fancy stuff from an Agatha Christie novel? We still don't know yet. We don't really know if it's thinking, and I guess humanity is in the process of finding out.
What's the difference between AI and machine learning?
Machine learning is what enabled AI to come into being. We've had machine learning for a long time where, you may have seen those pictures on the internet where you see muffins with blueberries and you see pictures of chihuahuas. And even to the naked eye, you look at a bunch of them and it's like, which is which? But when you have a closer look, it's easier for us to tell which is the chihuahua and which is the blueberry muffin. So machine learning is where you've got algorithms that are processing millions of images, millions of data points, and they're able to do that in super fast time because they're computers. But AI is supposed to build upon all of that machine learning and with even more intelligent algorithms to actually start to converse with us, as we've seen. I mean, we've had machine learning for years to help us automatically sort our photos out and group all the different photos into the particular person or pets or whatever it might be. And it's gotten smarter and smarter at being able to recognize if you type in, show me everybody with a red dress, or a yellow umbrella. But AI is where you can then actually do even more and ask more interesting questions, actually converse and get the opinion of AI and ask it for new ideas. I mean, again, which it's just compiling from the sum total of the internet. So before we could have AI, we needed machine learning, but machine learning is not AI. The two of them work together. AI uses machine learning as part of its many inputs to know what it is outputting.
That's Alex Zaharov-Reutt from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.